Hi everyone, welcome to another fun folding activity video. We're going to be doing this in our interactive notebook, or if you don't have a notebook that you've been putting your notes in, then you're going to go ahead and just do a piece of paper and you can glue it or tape it in there as well. So you're going to need just the blank piece of paper, your blank printer paper in 8.5 by 11. And the first thing you're going to do, you're going to go ahead and fold it. You're going to go the hot dog way. And then you're going to, so this is the longer way, the 11 inches is this way. You're going to fold it in half, unfold it, and then you're going to fold each of those sides, those 8.5 sides, into the center, and then again over here. Okay, you guys are going to then, we need 6 even spaces. If you guys can create a video of showing me how you can evenly space those, I would like to, I'll give you guys extra credit on there. That'd be awesome if you guys know how to do that. So please let me know. If not, you're just going to kind of estimate about the right spacing, how far it will be. So we are going to draw a few little lines here just so it's easier for us to, actually, I'm going to cut them first. So go ahead and take your scissors. And once you guys have your scissors, I'm going to go ahead and cut evenly. But before you guys start cutting, we're going to make these little flaps. So you don't want to be cutting this portion that's going to be getting glued down to your paper, your notebook, because this is where we'll be writing on. These are going to be the flaps. So before you guys actually start cutting, let me show you what I'm doing. So I'm just going to bring this. I already had measured mine out. I'm going to cut that portion. And if you guys see that, I only cut to the flap, so I don't actually have, it's not coming off. I'm not cutting this portion here. So you're only cutting this to make a flap. So I'm going to go ahead and do that for each of these sections here on both sides. So go ahead and do so. So now, as you guys can see, I actually have my 6 flaps over here. So 1, 2, 3, 4, 5, and 6. Again, this is just going to be my flaps that I'm going to be writing on as well. I'm now going to go ahead and do it on the other side. So go ahead and do that now. Okay, so now that we have all of our flaps here, what we're going to go ahead and do, we're going to start going through and doing our terms and our definitions. So go ahead, you guys can either use like any colored pencils for this, just to make it colorful. You guys can totally just write it in a single colored pen or pencil. It's up to you. So go ahead and grab whatever you want to start writing in. And our first term, our first little tab here is going to be the term proof. And then we're going to go ahead and actually open that flap, and we're going to define the term on the bottom portion right here. So a proof, this is a logical argument that shows ignore that little thing, a conclusion is true. I can't spell that. Okay, so it is true. So let me read that again because it's a little bit harder to actually see this. So this is a logical argument that shows a conclusion is true, and that should be written under the word proof. Okay, so now I'm going to go ahead and pick a different color. And we're actually going to go over to the right side here to write our next term. And our next term is going to be algebraic proof. So the difference, now we're going to write our term underneath there as well. So this one, it uses algebraic properties to show a conclusion is true. I'm going to go ahead and write that now. Okay, and now you guys can see, so uses algebraic properties. So we're going to be listing some properties so you guys know what they are to show a conclusion is true. And again, that's under algebraic proof. So far we have proof and algebraic proof with our terms underneath there. Okay, so we're going to continue down to the bottom left under the proof term. And now we're going to, our next term is equivalent equations. Okay, so equivalent equations, the actual definition that we're going to write under here is have the same solutions. Okay, so if you guys see this here, we have that it has have the same solutions, and that was under our equivalent equations. So now I'm going to go below our algebraic proofs and just keep switching colors, you guys. Below our algebraic proofs, we have combine like terms. Or another word that we might actually see that it says is simplify. So those are both actually the same terms that we will see. I'm going to go ahead and write that definition, and I'm going to give you guys an example underneath that flap. Okay, so I just showed you. So I just showed you guys our term here, combine like terms or simplify. So you're going to add or subtract those similar terms. Well, if we see here that we have, for an example, we have a 3x plus a 4x. Well, if I combine those like terms, I know I have 3x's here. I'm going to add it to 4 more x's. That means I'm going to get 7x. Okay, so that's all that means by combining like terms. Now I'm going to go ahead and go down to the bottom left term down here. And that one, this is actually where we're going to start writing our properties. So what I want you guys to do first is actually title kind of this section, and below we're going to name it properties of equality. Okay, just so we know this is going to be our list, and now we're going to now list those below there. So now I'm going to go ahead and pick a different color, and our first one is going to be addition. And underneath that one, I'm going to now write my actual definition, as well as give you guys an example of what the addition means. So we have if A is equal to B, then we have, if we were to add something to both sides of the equation, the expression, then that value should actually equal the same thing. So A plus C is equal to B plus C. So for an example for that, if I were to have an equation here where we had, I don't know, say 3x equals 5 plus x. So if I were, let's actually make that a negative. So if I were to add that 5 to both sides, then that means that would be addition property, and then I'd be making those sides, I was doing the same thing to both sides. Okay, so that was under the addition. Now we're going to go over to the right side, and we're going to see that we have the word subtraction. Okay, so then this one, instead of adding things to both sides, we're actually going to be subtracting things from both sides. So I'm going to go ahead and write that definition and give an example underneath that subtraction tab. Okay, so if you guys see that under here, if A equals B, then A minus C is equal to B minus C. So for example, if we had an equation as 3 equals 2x plus 1, in order to get that variable to solve by itself, I'd actually have to subtract 1 from both sides. So then that would leave with me 3 minus 1 is 2, and then I'd be left with 2x so far. So that step of that part of solving that equation was the subtraction property. So let me explain that addition property a little bit better, because if we were to solve for the variables here, we could add 5. Actually, let's add a 2 in front of this as well. So let's make that a 2x. So if I were to add 5 to both sides, then we would end up getting left off with a 3x plus 5 equals 2x. Actually, we didn't need to add that 2x, but it's okay. I'm just trying to show you guys that you can move things to one side by using addition. So now below that addition, you're going to pick a different color again, and we're going to go ahead and write multiplication. And under that multiplication tab, we're going to go ahead and write down the if-then statement for that property. Okay, so now you guys have the example. So if A equals B, then we have A times C, which is going to be equal to B times C. And for our example, we have x divided by 2 equals 3. So in order to get the variable by itself for this, I actually have to, it is being divided by 2. So the inverse operation of division would be multiplication, and I'd have to multiply both of those sides by 2 in order for those to divide out and leave me with x equals 6. Okay, you guys are going to start getting really good at this. We're going to be practicing these. So our next one that we're going to do is division. Go ahead and pick a different color. We'll do. Okay, so now we're going to go ahead and write that definition of the term of division, a property of division underneath that tab. Okay, so you guys see that we have if A equals B, then A divided by C is going to be equal to B divided by C. So in order to get our variable by itself in this expression, 3x equals 9, we'd have to divide both sides by 3, leaving us to have those divide out, and we get x equals 9 divided by 3 would be 3. Okay, but the process that you had to do, that first step, was to divide. All right, moving right along, we're going to go down to right below our multiplication symbol here. We're going to go down and the word is symmetric. Okay, so go ahead and write that word symmetric. I'm now going to open it up and we're going to write our if-then statement. So if A equals B, then B equals A. So a lot of the times for this example, you guys will actually solve for a variable and it might be on the wrong side or the wrong side. It means the same thing. So if I say like 3 equals X, well, by using the symmetric rule, you're able to bring over those values and just swap them because it's being symmetric. Okay. Now, continuing on to our next one, our next term we have is distributive. So again, distributive, distributive. We're going to go ahead and open that up and now put in our term. So if we have A times the quantity now of B plus C, then that's going to be equal to, we have to distribute this. So distributing means that we're going to be multiplying. So if I do A times B, we have AB. Then A times C would be left with AC. Okay. So then we'd say this. So then AB plus AC would be our solution. So let's do this with some numbers here. Let's just say we have 2 times x minus 1 equals, so this is my if. So if 2 is being multiplied by a quantity, something in parentheses, then that means we're going to be distributing this. So 2 times x, we always just put the number in front of the variable. And then we're going to go ahead and make sure you distribute everything to all that stuff in that parentheses. So 2 times a negative 1 is going to be a negative 2. So this is our if, this is our then. Okay. And then our last two that we have here, we're going to use the commutative addition. So commutative addition is our term. We're going to go ahead and flip that over so we can go ahead and write our actual definition for this. So if we have A plus B, that's equal to C, then B plus A is going to be equal to C as well. So for example here, if we have our problem such as, so if A plus B equals C, we have our example here, if then B plus A equals C. So for example, if 5 is equal to 3x plus 1, then all it's actually telling us is that we can switch just each of the equations on one side. So 1 plus 3x. As long as I'm bringing the signs with it and going a lot, like with the variables, like if this was a negative 1, that has to still be a negative 1. But this is a positive 3x. Okay. So again, let me better explain that. So it's just switching those, almost kind of like symmetric, but it's only switching one side of the expression or equation for that value. So let's go ahead and move on to our last term now. So our last one that we have is commutative multiplication. So our term, commutative multiplication. Now I'm going to go ahead and open that up and we're going to write down the definition. Okay, so our definition, if A times B equals C, then B times A equals C. So remember when variables are next to each other, you guys, that this actually means multiplication here. So for our example here, if I were to do a 3x equals 9, what that is going to happen is just going to switch those. So this is my if again, and then the then It's just going to switch these, but we don't typically see it written like that. That's why you can use the commutative multiplication property to then switch it back to the variable going in front of the coefficient. So again, you guys, if I went too fast, I want you guys to go ahead and slow down. You guys have access to this video for as long as you want. And so what you're going to do, make sure you have all the terms on the top like this. And then when you open it, you guys are able to go through and see all of the definitions and examples in here. So what we're going to do, we're going to go through some of these examples. You guys will have this worksheet right here. So let me show you this for now. So what you guys will do, you have these problems right here. So you're going to use your properties of equality foldable, this lovely thing that we just made, and you're going to write the property that we actually use in each situation. So if we take that, if x equals 2, then 2 equals x. Well, I'm going to go into my foldable here. I'm going to see what kind of examples actually look like that problem. Okay, so I'm going through, and I know I'm not really adding anything. I'm just kind of switching things. So I know that when I just switched things, I had commutative addition and multiplication down here. I was kind of just switching the numbers, but I've only been able to switch on one side of the equation. This one, I'm actually switching the x for the 2 and the 2 for the x. So that's still something that's symmetric, which means that I do have the symmetric property. So again, remember, we see things like this or like this. It's okay because it is symmetric. So what you're going to do in that blank position right here, so I have it, you guys will have this piece of paper, but I'm going to write in the blank right here, we're going to write symmetric. Okay, so that's all you guys are going to do on this portion of the worksheet over here. So when you guys get this, you'll go through the properties, and you're only basically writing the first step on what they did to the if and then the then statement. So then now, you guys, I'm going to show you guys an example on my thing here. You guys, I would recommend writing this down in your notebook or your notes. I'm just going to show you guys what a 2-column proof is. So what a 2-column proof is on here, if we see that we have properties of equality that use to justify, that's what we just did, our foldable, to help us solve our equations. So we're going to kind of go through the steps, and we're going to discuss like what's helping us do the equations. So for our 2-column proof, on that left side of your list, the left side of the list always has your statements. So left side, you guys are going to write this on your paper, on your actual homework. This has our statements. And then on the right side, we always have our reasons. And our reasons just happen to be the properties that we just came up with. So what we're going to do, I'm going to go ahead and now show you guys what I was just writing, but that's where this is actually where you're going to write it right here. So this is where, right here in that section. So again, the left side is your statements and your reasons are on your right side. Okay, so now I'm going to show you guys how to kind of go about filling out one of these. This is your challenge one. I want to see if you guys are able to do that, but you guys should definitely be able to do number 1 and 2. So let me go ahead and show you what we have for our 2-column proof. This one I just made up, so if you'd like to go ahead and use your example and write this down, it'll probably help you guys out a lot. So you're going to be given something. Remember, these are our statements. This is where we're going to be our reasons why we're actually doing this. So we always write down our actual problem we're trying to solve. This was given to us, so that actually is our reason why we get to write that down. So now if I'm trying to get this variable by itself, I'm trying to figure out x is being divided by 3. So that I know that the inverse operation of division is actually multiplication. So I know I'm actually going to have to multiply, use my multiplication property, or multiply. I'm okay right with you guys saying that. You can use multiplication property or say multiply. And now I'm going to go ahead, when I actually multiply both of those sides, you don't have to show, if you guys show the work here, it's actually a lot easier for you guys to see. So x equals, and then 2 times 3, which is 6. So that's actually what we wanted to prove. We wanted to see that x is equal to 6, that whatever we wanted to prove should be your last statement in your proof. And then we had to write down the step of what we actually did. In order to get to step 2, we had to multiply, and we had to use our multiplication property, which I just got from here. So any of those properties that you guys are going to be using are all listed down here. So through the rest of your worksheet, the next 2 or 3 problems that you're going to do is going to be values that you're coming from here, the actual terms, and you're going to be writing those statements and reasons why in your proof. All right, you guys, if you have any questions, please let me know if you do, and I can help you. That would be awesome. And then I would love to see you guys and help you out with your homework. All right, I'll talk to you guys soon. Thanks.